Well, welcome to this nudge video where I'll be giving you some ideas on how to get through MOP LC4 in the light and color unit. These MOP questions are going to build on your understanding of the primary colors of light by showing how those colors of light interact with real objects, such as in this question there's a shirt that appears to be cyan. I'm going to ask why it would appear to be cyan. And what I'm going to show you here could work with any color of shirt and any particular color of light. So I'm going to show you a strategy here that I hope is helpful, and it relies on your having a good understanding of these colors on the diagram here, which was part of the previous MOP. So understanding that the RGB light, that's red, green, and blue, when they're combined, we just call that white light. So from now on, when you hear white light, I want you to think R, G, and B separately. And then we're going to look at how they interplay with different materials. So let me give you this strategy, and I'm going to encourage you to make these drawings as you do these MOP questions as well as some later MOPs. And that is when they describe an object like a shirt that is cyan, actually draw an object like this and just label it cyan. And that's just the color that we call it when we see it under normal white light, like everyday light. And then they're going to describe how the object is illuminated. In this case, it's illuminated with equal intensities of R, G, and B. So what you're going to do is just draw maybe little light waves like that coming towards the cyan object, and it has R, G, and B light included in it. If it wasn't white light, you would have other components, maybe just red and green, or maybe just blue or something else. So when we look at this object, and so we're going to draw a person, and when they see cyan, that's because the light that has reached their eyes after reflecting off of this object, like the shirt, is not RGB anymore, but is only cyan. So if you look at our little color diagram, cyan is what you see when only the G and the B are reaching your eyes. So if RGB is coming to the shirt, but only G and B are leaving the shirt to hit your eyes, then where did the R go? Well, the R is actually absorbed into the shirt. For some reason, those particular wavelengths of light interplay with the molecules of the shirt itself, and in reality, if we could see what was happening, we would notice that that light causes those molecules to vibrate a little bit more than they were before. And sometimes when there's a lot of vibration, you can actually notice a temperature change in the object. That's why shining a light on an object sometimes causes it to warm up. So the R is absorbed, the G and the B, what we call cyan, is reflected. And so basically all of these kinds of diagrams can help you understand the difference between the light that's illuminating an object and then the light that's reflecting off of it. And that difference just tells you which type of light has been absorbed. So I think that would demonstrate this particular question, but there's a lot of others very similar where this diagram is going to be just as helpful. So you'll notice they call these complementary colors. So all of the colors that are absorbed, for example, R in this case, we say whatever's left over after the white light is hit and the red has been absorbed, what's left over, cyan, is considered the complementary color to red. So any two colors that combined make white are known as complementary colors. So in addition to red and cyan, we also have green and magenta that are complementary colors, and yellow and blue that are complementary colors. So when one of them is absorbed, the other remains to be reflected and seen by a person. So that's where we get that name from. So hopefully this has been helpful in your understanding of some of the interplay between colored objects and colored light. And if you have more questions about any of this, by all means come see me and we'll talk about it.